Hello friend, myself R.D. Mahajan. Today I am presenting my second video on vector calculus in which I will discuss two important points, uh, scalar point function, vector point function and gradient of scalar point function. Let us see the definition of scalar point function. When a scalar physical quantity is expressed from point to point, that word is important, point to point, in a region of space by continuous point function f of xyz, small f of xyz, function of three variable x, y, z, then the function is called as scalar point function. And the region where it is defined, that region is called as a scalar field. For example, temperature of body at a point, potential at a point, density at a point, pressure at a point. All these are the examples of a scalar point function. Then second is vector point function. It is defined as when a vector physical quantity is expressed from point to point in a region of space by continuous vector function f bar, capital F bar, of x, y, z, function of variables x, y and z, then that function is called as vector point function and the region is called as a vector field. For example, force acting at a point, electric field intensity at a point, velocity at a point, acceleration at a point, etc. All these are the examples of vector point. Vector differential operator denoted by del, operator of del operator. The vector differential operator del is defined as del is equals to I into dou by dou x plus j into dou by dou y plus k into dou by dou z. This is called as a vector differential operator. And rules for differentiation of vector point function are same as ordinary differential calculus. And therefore, if f bar of x, y, z be a vector point function, f capital, then its derivative with respect to t, df bar by dt, as it is function of more than one independent variable, we have to take its partial derivative. Therefore, dou f by dou x, applying chain rule, dx by dt into dx by dt. Next, dou f by dou y into dy by dt, dou f by dou z into dz by dt. And then cancelling dt throughout, we get df bar is equals to dou f by dou x into dx plus dou f bar by dou y into dy plus dou f bar by dou z into dz. Next point, gradient of scalar point function. Gradient of scalar point function. It is defined as del operator operated on that scalar point function f. It is del f and is gradient of that function f. And to obtain the value, we substitute the operator del here. That operator del is I into dou by dou x plus j dou by dou y plus k into dou by dou z. That operator we have to operate on scalar point function f, and operating it on f, we get dou f by dou x into I, means derivative of that function with respect to x into I, partial derivative of that f with respect to y into j, and plus partial derivative of f with respect to z into k. This is the definition of grad f. And if you observe the quantity, it is a vector quantity. Therefore, grad f is always a vector quantity. Then physical significance of gradient. For that, draw this figure. In this figure, we have that scalar point function f of x, y, z by this figure. It is representing that scalar point function. At point P, we have a tangent to the surface. Therefore, PT is the tangent at point P, and a vector which is perpendicular to this tangent is a normal vector, a vector along that normal, and therefore grad f is normal to the surface at point P. Means along this normal we can determine that grad of that scalar point function. Therefore, remember this as a physical interpretation of that quantity. Whenever we require to find grad f, it is nothing to the surface at point P. Therefore, along this normal, we get that grad f. A grad function, let us see some important properties of that gradient. For that, if f of xyz, small f of xyz, and g of xyz be two scalar point function, both are the scalar point function, then first rule, grad of sum of the two functions is nothing but sum of grad of that function. It is grad f plus grad g, and when it is grad of subtraction of two functions f minus g, it is subtraction of two grads, that is grad f minus grad g. Then second rule, gradient of product of two function f into g, where to apply product rule. Therefore, first function f, gradient of g, plus second function g, gradient of first function. Then gradient of f by g, grad of f by g, where to apply quotient rule. Therefore, as per that rule, it is g into grad of f minus f grad of g divided by g square. And fourth, if grad of that function is 0, it is if and only if that function is constant one. Means if grad value is 0, then function is constant, or we can go reverse way also. If that function is constant 1, its grad is 0. That's why this word is if and only if. In both the direction we can apply this result. And the last one, an important one, grad of f of u, function of function. Therefore, it is f dash of u into grad u, that is nothing but f dash of u into gradient of that function u. Therefore, remember all these important properties or the rules for a gradient. In my next video, I will discuss some problems based on gradient, how we can determine the gradient of that given function, scalar point function. If you are watching my videos, please like and share it, as well as subscribe to my channel to get new updates or new videos. Thank you very much.